Welcome back everyone to part 2 of logistic regression with scikit-learn. In part 2 we're focusing on creating and training the logistic regression model. Keep in mind we won't focus too much on the hyperparameters of logistic regression. We'll discover those in more detail when we talk about multi-class logistic regression. Let's head to the notebook where we left off last time. Okay, here I am at the notebook where we left off last time. Recall that our data frame has the age feature, physical score feature, and then the 1 or 0 test result. So clearly our features are age and physical score, and the y target label is test result. Let's separate out our features, x, versus our label y. We will say x is equal to df, drop the test result, and then do this along axes, equals 1, and then y is equal just to that test result column. All right, next thing, just like with linear regression, it's a good idea to scale these features, especially if I want to compare coefficients directly to each other. So we'll do the following. We're going to say from sklearn model selection, import train test split, since I always want to split first before I do the scaling. And then we'll also say from sklearn preprocessing, import standard scalar. So let's do our train test split first. I'm just going to tab autocomplete this and then do shift tab. Scroll down till we find that classic line of code. And let's copy and paste this. And then stick it in here. Okay. So for this particular case, just so it matches up with the lecture notes, let's go ahead and say that our test size is 10%. That's what we have in the lecture notebook. And then we'll say our random state is 101. So then we're going to run this. We've done the train test split. Now let's create a scalar object. Have it be an instance of standard scalar. And we'll create our scaled xtrain data is equal to scalar.fitTransform xtrain. And then our scaled xtest data is equal to scalar transform xtest. So as a quick note, just a reminder, fit transform essentially does the fit and the transformation in one step. And we're only going to fit on the training data, which is why I only called .transform on the test data. I don't want any information leaking from my test data, including things like scaling information. Now it's time to actually create the logistic regression model. We'll say from sklearn.linear model import the logistic regression. And keep in mind, there's actually two versions of logistic regression. One has built-in cross-validation. We're going to talk about how to use a generalized cross-validation with logistic regression to explore different values of C, which we'll learn about later, as well as versus an L1 penalty or an L2 penalty. That's all available to you within logistic regression. In fact, if you call help on logistic regression and then run this, you'll notice that there's this C value. By default, it's 1.0. And we'll be able to play around with that. You'll also notice there's a penalty value, L1 or L2. And if you scroll down, you'll realize that, let me just zoom out one level here so we can read this easily, that the penalty terms we previously discussed, that is L1, L2, and elastic net, those are all available to you in logistic regression as well. Because recall, we're still performing gradient descent. We can just add in this penalty factor of what we're trying to minimize. And you can do L1, L2, and elastic net. And as we know, there's coefficients associated with these penalty terms. And if you scroll down, that is what the C value is. It's actually the inverse of the regularization strength. And typically what you're going to do is you're just going to add in a set of different C values to check in a grid search of cross-validation to figure out the best C value. But for right now, we just want to explore the basics of logistic regression. So we'll just leave everything as the default. So keep that in mind, we're just using defaults right now. We'll show you in the next series of lectures how to actually test out different penalties as well as different C values for how strong those regularization terms should be. So I'm going to comment this out and let's actually create an instance of our log model. Let me zoom back in here. We're going to say log model is equal to an instance of logistic regression. And then I'm going to fit this to my scaled data. We'll say log model, and this is fit to scaled xtrain on ytrain. There we go. Okay, so obviously this looks really familiar to us because this is pretty much the exact same process we used with linear regression. Now that I have a fit model, there's a lot of information I can grab from this. We'll have first the coefficients. So we have log model, coefficients, and these are the coefficients we can begin exploring, and I'll be able to then perform things like predictions. So I'll be able to say ypred, or ypredicted, is equal to log model predict scaled x test, run that, and now I have my predictions, and you'll notice my predictions themselves are just ones and zeros. Later on, we'll see that if I wanted to actually predict the probabilities, there are both the option to predict the log probability or predict the probability. So I can say predict probabilities, run that, and now you'll notice that I have two sets of terms. It's essentially the probability of this instance belonging to the 0 class versus the probability of it belonging to the 1 class. Okay, so there's still a lot more we need to talk about in regards to model performance and model interpretation for logistic regression. So before we dive straight into predictions, probabilities, accuracy scores, and the confusion matrix, let's take a little bit of a break in order to understand what these metrics are actually talking about in regards to any classification model. So we're going to take a quick aside to talk about things like classification metrics, accuracy, recall, precision, the confusion matrix, and ROC curves. I'll see you at the next lecture where we take a little bit of a theoretical aside.